Keeping in mind that only square matrices have inverses, but not all square matrices have inverses, let's investigate how to calculate the inverse of a square matrix when it exists. 2 by 2 matrices are the easiest to work with because the following formula will crank out the inverse for us. If A equals row 1 AB, row 2 CD, then A inverse is equal to 1 divided by the quantity AD minus BC, end quantity, times the matrix row 1 D negative B, row 2 negative C A, as long as the denominator of the fraction is not 0, i.e., as long as AD minus BC does not equal 0. Let's explore this formula a little further by working on a couple of sample problems. Example 1. Find the inverse, if it exists, for A equals row 1, 7, 4, row 2, 3, 2. Okay, you probably already noticed this, but the denominator in the inverse formula is the product of the entries along the main diagonal minus the product of the entries along the minor diagonal. So our denominator should be 7 times 2 minus 4 times 3. And since this difference is not 0, we can proceed. You also probably already noticed a shortcut for getting the matrix in the inverse formula. We just swap the entries on the main diagonal and then we simply slap negative signs on the entries along the minor diagonal. Now we just perform the arithmetic. The denominator is 14 subtract 12, which is 2. So we have 1/2 times the matrix, row 1, 2, negative 4, and row 2, negative 3, 7. Multiplying each entry by 1/2 yields A inverse is equal to row 1, 1, negative 2, and row 2, negative 3 halves, 7 halves. How would you verify that we have indeed found the inverse of A? Yep, you would multiply A times A inverse and then multiply A inverse times A to see if each product is, in fact, I. Okay, let's try another example. Find the inverse, if it exists, of A equals row 1, 6, negative 3, row 2, negative 8, 4. Since A is another 2 by 2 matrix, we just set up the formula. And we calculate the denominator by taking the product of the entries along the main diagonal and subtracting the product of the entries along the minor diagonal. Oh, but wait! Look at that denominator. We have 6 times 4 subtract negative 8 times negative 3, which is 24 subtract 24, which is 0, and the denominator cannot be 0, so no inverse matrix exists for A. In the next video, we'll learn how to find the inverse, if it exists, for a square matrix that is larger than a 2 by 2.